Okay, here's example 4 with right triangle trig, things like that. So this is really going to be a lot like example 3. So here we're given that cosecant of beta is 2. So this is beta, so we've talked about that in an earlier video. It's just another lowercase Greek letter. It's one of the letters commonly used to denote angles. So there's alpha, beta, gamma, and theta that are more commonly used than some of the others. So anyway, just to get some practice using the different letters, cosecant of beta is 2. And we want to find the exact values of the other 5 trigonometric functions of beta. Okay, so so what are we going to do? Well, let's we don't have a picture to work with here, so let's go ahead and draw a triangle to make things easier for ourselves. So we're going to draw a triangle, a right triangle. So here's our right angle, and then we'll put beta over here. So again, we could have just as easily put beta up here, but we'll just put it in here to make things simple. So let's make that a little more legible. Okay. Well, not much better, but all right, anyway, here's beta. So we're told that the cosecant of beta is 2, so how are we going to label the triangle? Well, there's 2 ways we can think about this. If you remember, cosecant is the hypotenuse over the opposite side, right? Or if you don't remember that, hopefully what you do remember is that cosecant is the reciprocal of the sine, and then you could use the fact that sine is the opposite side over the hypotenuse. But in any case, what we could do is, let's say this. So 2 is the same thing as 2 divided by 1, okay? And the cosecant is the same thing as, so the cosecant of beta is the same thing as the hypotenuse over the opposite side, okay? So the cosecant of beta, that equals the hypotenuse over the opposite side, and 2 is the same thing as 2 over 1. So just like in example 3, let's say, okay, let's let this be the hypotenuse, and we'll let this be the opposite side. Okay, so we're going to say 2 is the hypotenuse, and then the opposite side is 1. Okay, so that's what we could do there. All right, now it's pretty much just like examples 1 and 2, right? So what we could do, or what we should do now is say, all right, so I don't know what this side is, so I'm going to have to call it x. Okay, and then we're going to have to go through some steps here to figure out what x is using the Pythagorean Theorem. So then once we have x, we'll have all 3 sides of the triangle, and then we could find the other 5 trig functions of beta. Okay, so x squared, so Pythagorean theorem here, x squared plus 1 squared equals 2 squared. Okay. So x squared equals, well, 2 squared is 4, 1 squared is 1, so this is, let's just show all the steps. X squared plus 1 equals 4, so we'll subtract 1 from both sides, so then x squared equals 3. Take the square root of both sides, x equals, so again, just like in the first 3 examples, there's a positive and a negative root, but x represents the length of a side of a triangle, so x has to be positive, so we only take the positive root. So x is the square root of 3. So let's write that here, x equals the square root of 3. Right, now we have all 3 sides of the triangle, right? So here's root 3, here's 1, and then here's 2. Okay, that's great. Now we can easily find the other 5 trig functions, so let's go ahead and do that. So we'll separate this space here. Okay, so let's do it how we always do it. Sine, that's what we want to do first, sine of beta equals. Okay, now 2 things here. We could look at the triangle and get the sine of beta, which is going to be very straightforward, or we could use the cosecant of beta to get the sine, which is also straightforward. So remember, the sine is the reciprocal of cosecant, right? Sine and cosecant are reciprocals of each other. So if the cosecant is 2, if the cosecant of beta is 2, then the sine of beta is going to be the reciprocal, which is 1/2. Or we could remember sine of beta is opposite over hypotenuse. If here's beta, then here's the opposite side, here's the hypotenuse. So 1 over 2. So 2 different ways of thinking about it, and it's the same answer either way. Okay. Cosine of beta is adjacent over hypotenuse. Okay, the adjacent side is root 3, which we just found out with the Pythagorean theorem, and the hypotenuse is equal to 2, which we figured out from the fact that cosecant of beta is 2. Okay, so adjacent over hypotenuse is root 3 over 2. So cosine of beta is root 3 divided by 2. How about the tangent of beta? So tangent is opposite over adjacent, so here's beta, so the opposite side is 1, the adjacent side is root 3. Okay? So opposite over adjacent is going to be 1 over root 3. And again, I've talked about it a lot in the previous videos, so you might have guessed by now I'm not really a fan of rationalizing the denominator if it doesn't simplify anything. And in this case, it does not simplify anything really. But if you have to do it, or if you insist on it, multiply by root 3 over root 3, and you'll get root 3 over 3, okay? Which really isn't any more simplified, I don't think. But if you have to do it, or if you really want to, then this is what you'll get. But I really have to insist that this is a better answer if you're allowed to give it. Okay, so sine, cosine, and tangent, so we have those now. Now what about the other three? Cosecant, we were given that, so we don't need to find that. We only have to look for the other 5 trig functions. We were given cosecant, and actually we don't need to use it anymore, so let's not even bother writing it. Okay, because we don't need to use it, so there's no point in writing it down anymore. And we're only looking for the other 5. So cosine of beta, we already have cosecant, so now let's get secant of beta. So that relates to the cosine. How? Well, remember, sine and cosecant are reciprocals, right? So similarly, cosine and secant are also reciprocals. So the secant of beta is the reciprocal of the cosine. And if the cosine is root 3 over 2, then the reciprocal is 2 over root 3. And again, if you have to rationalize the denominator, then 2 over root 3 multiplied by root 3 over root 3. So that's going to give you 2 root 3 over 3, okay, which I don't believe is any more simplified than this, but if you got to do it, you got to do it. So 2 root 3 over 3, okay? All right, and then last, cotangent of beta. So cotangent is the reciprocal of the tangent, so if the tangent is 1 over root 3, then the reciprocal is just root 3 over 1, which is the same thing as root 3. Okay? Or if you were using this one, tangent of beta is root 3 over 3, then cotangent of beta would be 3 over root 3. And then to rationalize that, you just multiply by root 3 over root 3. Then you have 3 root 3 over 3. The 3's cancel, and you just get root 3. Okay, so either way, no matter how you, no matter which route you go, whether you're rationalizing or not, you'll end up with root 3. Okay. Okay. So that's it for example 4, and this is the final answer here. We were looking for the exact values of the other 5 trig functions of beta. So remember, exact values means leave all the square roots there, don't approximate anything with the decimal. Square root of 3 cannot be exactly expressed as a decimal, so just leave it as the square root of 3. Don't toss it into a calculator and approximate, so just make sure to give exact answers when specified. So that's example 4 with right triangle trig.